All right, friends. Today we worked on generating equivalent expressions, and this is like the third time I tried to tape record this lesson. I'm running out of space on my phone, so I'm going to try and be quick and upload this. And then after I'm done, I will go over some of the problems that we did today with you. Okay? So, again, we're going to practice working with equivalent expressions. Remember, equivalent expressions are different ways of writing the same mathematical idea. It's almost like saying hello in 4 different languages, all right? So here we go. What are equivalent expressions? Expressions that have the same value but look different. Again, like saying the same thing in different ways. So 2 plus 3 is 5. They are equivalent. 2 plus 3 and 5 are equivalent, right? What would be another way of showing 5? We could say 2 plus 3 is 5. 1 plus 4 is 5. Those are 2 equivalent, equivalent expressions. They both equal 5, all right? Now, can you think of another way to write 4 times 2? We could write 4 times 2, and then we could say 8, right? Those are equivalent. We also could do something like this. We could make it more like a 6th grade level, and we could pull out a 2, and we could say 2 times 2 times, so 2 times 2 is 4. What times 2 is 2? 1 is 8. Because 2 times 2 again is 4 times 2 times 1 is 2. And there you get 4 times 2 is 8. So that's another way of showing 8. That's equivalent to 8. All right. Let's see. I have a dot there. So what are we using to get equivalent equations? We're using the distributive property. We talked about that this morning, right? Or today, this afternoon. The distributive property. In the distributive property, we're just giving things out, right? We're giving something out or away. So let's look at A times B plus C equals. We're going to distribute it. We're going to give the A to B, and we're going to give the A to C. Kind of like when we hand out papers. We give papers to everyone. I might say, can you distribute these papers out to all of the classmates? You're going to give it. So if we give A to B, we get AB. We're going to go plus. And if we give A to C, we get AC. A times C. So A times B plus A times C is equivalent to A times B plus C. And right here, let's look at the tacos. 3 times 2 tacos plus a can of pop. If we distribute it, we're going to give this 3 to the 2 tacos. We get 6 tacos, right? And if we give the 3 to the 1 can of pop, we get 3 cans of pop, right? 3 times 1 is 3. We just distributed. We gave the 3 to the 2 and to the 1, didn't we? All right. So now we also can combine like terms when we are making equivalent fractions. Adding or subtracting terms with the same variables, or multiplying terms with the same variables. Remember, the variable is the letter. Okay, and remember, terms are between mathematical signs, right? So we have 3 terms in that expression. We have 3 terms in this expression, all right? They are the coefficient in the variable, or the constant, or the variable on each side of your math sign of addition, subtraction, or multiplication, or division. So right here, can we combine any like terms in this equation? 3y plus 4x plus 2y. Remember, we're looking for something that has the same variables. Well, I see y as a variable here, and I see y as a variable there. So can we combine them? Yes, we can. We can say 3 and 2 is 5y plus 4x. This expression is equal to that expression, okay? Now what if this was my expression, 3y plus 4x, and that's all I had? Could you combine any like terms? No, you could not, because you have no variables that are the same. You will have a y and an x, and that's it. Okay? What if I had something like this? 3y plus 2y squared. Do you think you could combine those? Because we are going to look at those, I believe, tomorrow. So I'm going to have you think on that. Are these like terms or not? One has an exponent. We're going to learn about that hopefully tomorrow. So I'm not going to give it away yet. All right. You can also use factoring to find equivalent expressions. Factoring, we did some of that today in some of those problems you were working on. So when you distribute, you give. When you factor, you pull out.